Okay, so these are the formulas for engine performance analysis, and the first formula we have is our W is equal to PVD, where W means power from your first law of thermodynamics. Power is equal to pressure times volume. dV can be written as length L times A times N times K times S, where your L is your length of stroke, your A is your area of bore, and we know that area is equal to pi d square over 4. Your area is equal to pi d square over 4, where that d is your diameter of bore. So in a question where you see stroke, they are referring to the length. Where you see bore, they're referring to the diameter. So let's continue. We have our N, which is our engine speed, our K, which is our type of stroke, and you know that for your 4-stroke engine, your K is equal to half, and for your 2-stroke engine, your K is equal to 1. Then S is your number of cylinders. Now let's go back now. So if we input this dV into this formula here, we have W is equal to pressure length, that is Planck's. Now there are multiple kinds of power. We have our indicated power, we have our brake power, and we have our mechanical loss or power loss. The difference between these three is the pressure. So for our indicated power, we have indicated pressure. That is Wi is equal to Pi length. That is here we have our indicated, where Wi is our indicated power and Pi is our indicated pressure. Now we have brake power. Brake power, which is Wb, is equal to Pb times length, where Wb is brake power and Pb is brake pressure. Now brake power also has another formula where your length isn't given, but you are given your torque, the torque of your engine. That is your Wb is equal to 2 pi n t. This t represents torque. That's why I wrote it like this, in this manner. Now, another form of power is your mechanical loss or your power lost. That is Wl. The L represents loss, is equal to your pressure loss times length. That is mechanical loss is equal to pressure loss times length. Okay. Now recall that your losses in an engine is equal to your indicated power minus your brake power. Your indicated power minus your brake power. Also, in some questions, they will mention things like loops. If you're in a question and you see anything regarding loops, we'll get back to this in one of the solved questions later. Where you see total loop, the pressure or the energy in a total loop, that refers to the loop in the indicated power parameters regarding indicated power, indicated pressure. When they are talking about working loop, we are talking about your brake power and your pressure in your brake power, the brake power loop. That working loop is equivalent to your brake power. So that is like if they say the pressure in the working loop, we are talking about the pressure, your PB, your brake pressure. If they are talking about your pumping loop, you're talking about the loop in losses. That is your, if they say the pressure in your pumping loop, that is your pressure loss. Okay. So now let's go to here. We have efficiency M is equal to WB over. We have efficiency M is equal to WB over WI. You know that this is mechanical efficiency, where your WB is your brake power over your indicated power. Now there's another type of efficiency. We have our thermal efficiency, which is W over Q. You know that Q can be given with the formula MF, that is your mass of fuel, times your LCV. Now this W can either be your indicated power or your brake power. The difference between both of these, or how would I say, whichever one you choose to put, determines the kind of thermal efficiency you get. Okay. If you choose to use your indicated power, you are going to get your indicated thermal efficiency. If you choose to use your brake power, you are going to get your brake thermal efficiency. Now, Recall that your mechanical efficiency is equal to your WB over WI. If I was to write my brake thermal efficiency over my indicated thermal efficiency, if I open it, I know my brake thermal efficiency is equal to WB over Q. My indicated thermal efficiency is equal to WI over Q. If I rearrange this, these Q will cancel each other out, leaving WB over WI, and we know that WB over WI is equal to mechanical efficiency. So you can as well write mechanical efficiency is equal to your brake thermal efficiency over your indicated thermal efficiency. Okay, so the next formula we have is our air-fuel ratio, which we all know is the mass of air over the mass of fuel. Your MA is your mass of air, your MF is your mass of fuel. The next is your efficiency V. That is your volumetric efficiency. Your volumetric efficiency is your volume of air, or actual volume, over your swept volume. The volume of air over your swept volume. We know that the swept volume also has a formula of Planck's, like we used previously, that dV. Swept volume is Planck's. I'd advise looking for the swept volume first, always, because swept volume is used to solve a lot of problems. So if you have the values for your L, A, N, and Ks, find your swept volume. Now, let's say recall from our normal law of density. Density is equal to your mass over your volume. If you rearrange this to make your mass subject of formula, you're going to have your mass is equal to your density times your volume. Now, we can write this as your mass of air is equal to your density of your density of air times your volume of air. You can still write it to be your mass of fuel is equal to your density of fuel times your volume of fuel. Next, we have our recall. If you are given your density is not going to be given in the question, but you will have your parameters for your pressure, your gas constant, and your temperature. How will you find your density? Now, what you're going to do is recall PVT. This isn't something you need to know. Okay, recall PVT. PV is equal to MRT. Now, in this equation here, we are trying to make M over V subject of formula, because M over B is density. So what we're going to do is divide both sides by RT. That is RT. This cancel out. We're going to have M is equal to PV RT. Then we divide both sides by V to remove the V from this side and take it here. This is going to leave us with M over V is equal to P divided by RT, and M over V is density, so you have your density is equal to P RT. Okay, so we can now say that our density of air is equal to your pressure of air divided by your gas constant of air times your temperature of air, or your density of fuel is equal to your pressure of fuel divided by your gas constant of fuel times your temperature of fuel. You can now say the next thing we have is our specific fuel consumption. Now, the specific fuel consumption is equal to your mass of fuel times 360 over your power. This power could either be indicated or specific. Like I said before, the only difference is which power you're using. If you use your indicated power, this is going to be your indicated specific fuel consumption. If you use your brake power, it is going to be your brake specific fuel consumption.